This is the exam 3 review. Problem 1, evaluate the function at the given value of the variable. So we're going to evaluate this function at 2 and at -2. So let's evaluate this function at 2. To evaluate this function at 2, we are going to replace the x in the function with the number 2. So we have 3 times 2 squared plus 5 times 2 plus 4. And so now we're going to do the arithmetic here. So 2 squared is 4 plus 5 times 2 plus 4. So that's going to be 3 times 4 is 12. 5 times 2 is 10 plus 4. So that's going to be 12, and 10 is 22 plus 4 is 26. Now we're going to evaluate this function at -2. So we're going to replace the x with -2. Three times -2 squared is 4, plus 5 times -2, plus 4. So we get again, 3 times 4 is 12. But that second term, since x is -2, we're going to get -10. 5 times -2 is -10, plus 4. 12 minus 10 is 2. 2 and 4 is 6. So we get 26 here and 6 here. The second problem, we're going to do a graph by plotting points, and they're going to ask us to find 5 different ordered pairs to plot. And the function that we're finding the ordered pairs for is f of x equals x minus 3. And we're going to do that for values of x from 0 to 4. So we're going to evaluate this function at 0. 0 minus 3 is -3. So type that in here. F of 1 is 1 minus 3, which is -2. F of 2 is 1 minus 2, which is -1. F of 3 is 3 minus 3, which is 0. And f of 4 is 4 minus 3, which is 1. And then I'm going to pick 2 of these points to plot. In my lab math, I'm going to pick the line tool, and I'm going to plot 2 points. And I'd probably pick the intercepts because those are just the easiest for me to plot. So the first ordered pair there, 0, -3, is the y-intercept. So I would plot that, 0, -3. And then when we evaluated for x is 3, we got y is 0. So that is the x-intercept. So I would plot that. And then, of course, my lab math's going to draw the line for me. All right, problem 3, is that a function? And the answer is yes, it is. It is a function because it passes the vertical line test. I can draw an infinite number of vertical lines through that graph and not hit that graph in more than one place. So yes, it is a function. It passes the vertical line test. All right, problem 4. Find the slope of the line passing through the pair of points, or state the slope is undefined. Then indicate whether the line through the points rises, falls, or is horizontal or is vertical. Okay, to find the slope, we take the change in y's over the change in x's. So I'm going to let this first point be x1, y1, and the second point be x2, y2. So in my formula, y1 is 6 y2 is 4, x1 is -1, and x2 is 3. So let's plug and chug. So we have 4 minus 6 over 3 minus a minus 1. So be careful with your signs. So I'm going to get -2 over 3 plus 1, which is -2 over 4. I can divide numerator and denominator by the number 2, so that's -1/2. A slope that is negative falls from left to right. If it's positive, it rises. If it's negative, it falls. So this line is falling from left to right. Problem 5, graph the linear function using the slope and the y-intercept. That constant right there is the y-intercept. So the y-intercept is the point 0, 1, and the slope is that coefficient that we're multiplying times x. So the slope is -5 over 6. So we're going to start at the y-intercept at 1, and then we're going to use the slope. Since it's negative, I'm going to go down 5 and to the right 6. So I'm going to go down 5. 1, 2, 3, 4, 5. So I'm going to end up at -4. If I'm starting at 1 and I'm going down 5, I'm going to go to -4, and then I'm going to go to the right 1, 2, 3, 4, 5, 6. So I end up at the point -4, 6, okay, and then draw my line. And of course, in my lab math, you have the line tool that you're going to use to draw that line. Okay, the next line to draw is going to be a horizontal line. If you have an equation where you have y is equal to a constant, that is a horizontal line at that y value. So this is a horizontal line because everywhere y is the same value, it's -1. So we're going to go to y equals -1, and we're going to plot another point at -1, and that'll draw us a horizontal line. All right, problem 7 is a vertical line. If we have x is equal to a constant, that is a vertical line at that x value. So we're going to go to x is 3, and then we're going to pick another point where x is 3 and draw the vertical line. All right, the next problem 8. Write the point slope form of the line satisfying the given conditions. Then use the point slope form of the equation to write the slope intercept form of the equation. So point slope form is y minus y1 equals the slope m times x minus x1. X1, y1 is your point that they give you. So x1 is 16 and y1 is -5. And then they give you the slope. It's -3 over 4. Okay, so now it's a plug and chug. We have y minus a -5 is equal to -3 over 4 times x minus 16. And they will want you to change that minus a minus to a plus, and that's all you need to do to put it in point slope form. So y plus 5 is -3 over 4 times x minus 16. So that's what I put in that first field. The next step is to solve this equation for y, to put it in slope intercept form. So I'm going to first distribute the -3/4 across. So that's going to be -3/4 times x. And I'm going to have to multiply the -3/4 times -16. So that's going to give me a plus. The 4 will go into the 16 4 times. 3 times 4 is 12. So that's going to be plus 12. So y plus 5 is -3/4 plus 12. We're going to subtract the 5 from both sides. And we get y is -3/4 times x plus 7. So that's what goes into that second field. All right, now the next problem, they don't give you the slope. You're going to have to find that first. So I'm going to do this down here. So the slope again is the change in the y's over the change in the x's. So I'm just going to make this x1, y1, x2, y2. So we have 4 minus, and I can't read that, -6. Couldn't read it because I wrote over the top of it. But y1 is -6. And then the difference in the x's, 1 minus a -4. So that's going to be 4 plus 6 over 1 plus 4, which is 10 over 5. 10 divided by 5 is 2. So the slope is 2. So now using the point slope equation, y minus y1 is equal to m times x minus x1. And I'm just going to stick with the point being that first point. So we have what? Y minus. Actually, if it were me, it really doesn't matter which point you use. And I'd probably use the second one. To be honest with you, the second one, both coordinates are positive. So there's probably a less likely chance of me making a sign error. So I'm going to use 1 and 4 just for ease of sign errors. So slope is 2x minus 1. It does not matter which one you use. It doesn't matter which point you use. So I'm just going to use the easiest one. So we get y minus 4 is equal to 2 times x minus 1, and that is that first field, by the way. Minus 4 is 2 times x minus 1. So that is point slope 4. And now I'm going to solve for y. I'm going to distribute, oops, the eraser came on. I'm going to distribute the 2 across. So I get 2 times x times 2 minus 1. It's minus 2. And then add 4 to both sides. Y is 2x plus 2. Y is 2x plus 2. All right, problem number 10. Solve the system by graphing. All right, so I'm going to graph both these lines. I would graph this line using a point, excuse me. It helps if you write this correctly. Slope intercept, because it's in slope intercept form. The second line, I would use intercepts because it is in that kind of general form where it would be easy for me to find the x and y intercepts. Okay, so the first line, the y-intercept is 6. And the slope is 3. So I'm going to go to 6, which is kind of hard to see on this graph. It's right there. And then I'm going to go up 3, 1, 2, 3, and over 1. And I'm going to do my best to try to draw a straight line. And then I'm going to go down here and do a little, see if I can draw this. On my lab math, you'll have a much better, it'll be a lot easier for you to draw than me to kind of freehanding it on this screen. All right, so the second one, I said I'm going to graph that using intercepts. To find the x-intercept, we set y equal to 0. So set y equal to 0, minus 3x minus 2 times 0 is 24. So minus 3x is 24. X is negative 8. We're going to divide both sides by negative 3. Okay, to find the y-intercept, we're going to let x be 0. So we have negative 3 times 0 minus 2 times y is 24. So we get negative 2y is 24. Divide both sides by negative 2. And the eraser just came on again. And we get y is negative 12. So we're going to plot negative 12, which is right there, and negative 8, which is right there. So the x-intercept is negative 8, the y-intercept is negative 12. So we're going to graph those. Let me see if I can draw a straight line. Reasonably, decently, maybe. Okay, it is, like I said, when you graph this on your computer, it's so much easier to see, but it looks like it's intersecting right in here. And that appears to be x is negative 4 and y is negative 6. So it appears to be intersecting at the ordered pair negative 4, negative 6. And that is how I must input my answer, is as an ordered pair. So I separate the x coordinate and the y coordinate by a comma, and I put parentheses around it. Now, since I'm graphing this, I'm going to check it because I'm not too sure about how good my graph is. So I'm going to check it in the first equation. So I have negative 6 is 3 times negative 4 plus 6. I replaced the x with negative 4 and the y with negative 6. Negative 6. Negative 6. Does that equal negative 12 plus 6? Yes, it does. And now I'm going to replace the x and y in the second equation. So I have negative 3 times negative 4 minus 2 times negative 6. Lots of negatives there. Negative 3 times negative 4 is plus 12. I got a minus in the second, so that's going to give me plus. 2 times 6 is 12, and 12 plus 12 is 24. So that is the solution to that system of equations. The next one, solve the system by substitution. As I said in class, if you're going to use substitution, you should have a coefficient on the x or y to be the number 1, because it makes it much easier for you to solve for that variable. So since there is an understood 1 right in front of that x, I'm going to solve that for x. So solve this for x. To do that, I'm going to subtract the 2y from both sides. So over here on the right, I have 3 minus 2y. And on the left, I have x. So x is equal to 2y. Now, x is equal to 3 minus 2y. So now I'm going to take that expression right there for x, and I'm going to substitute it in for x in the second equation. So where there's an x in that second equation, I'm going to replace it with the expression 3 minus 2y. And then solve the equation in x. So I distribute the 3 across. 3 times 3 is 9. Distribute the 3 across. 3 times minus 2 is minus 6y plus 5y is equal to 3. I'm going to collect like terms on the left-hand side. Minus 6 plus 5 is minus 1. So it's minus 1y is equal to 3. I'm going to move the 9 by subtracting it from both sides of the equation. I get minus 1y is equal to negative 6. Divide both sides by negative 1, and y is equal to 6. Now that I know what y is, I'm going to back substitute into this equation right here. So we're going to take x plus 2y is equal to 3. Excuse me, the boxed-in equation. I don't know what I'm doing. I'm going to do this equation that I have boxed in. So the x equals 3 minus 2y. It would make sense I would use that one, wouldn't it? So we're going to plug in the 6 for y. So we get 8 minus 12. 8 minus 12, the difference between 8 and 12 is 4. 12 is bigger and it's negative, so the result's going to be negative 4. So my ordered pair is negative 4, 6. And I do want to check that to make sure it works. So try it in the first equation. Negative 4 plus 2 times 6, is that 3? I got a boo-boo somewhere, folks. Apparently I can't add somewhere. Somewhere I can't add. Right here. See, I can't read my own writing. It's right here. That's a 3. That's not an 8. That's because I'm writing messily. So let's change that to 3. Let's change that to 3. See how helpful checking is? If I hadn't checked this equation or this system, I wouldn't know that I was wrong. So checking helped me discover that I made an error. How helpful is that? So now 3 minus 12 is negative 9. I am so glad I checked this. Now let's see if that works. Okay, now let's see if that actually checks. So I have in the first equation, I would have negative 9 plus 2 times 6. Is that equal to 3? Yes. Negative 9 plus 12 is equal to 3. Let's check it in the second. I have 3 times minus 9 plus 5 times 6. Is that equal to 3? Well, that's negative 27 plus 30 is equal to 3. So I found my error in my messy handwriting. I thought that 3 looked like an 8. Let's fix that, make it look like a 3. And so I made an error, but I found that error by checking my solution in the original system. All right, solve by addition. I'm going to do that down here. The addition method, you're going to multiply one or both of the equations by an appropriate constant so that when you add the equations together, either the x's or the y's are eliminated. So what you want to do is you want to make the coefficients on the x's or the coefficients on the y's add to the number 0. So it appears to me that the easiest thing to do would be to multiply this top equation by 5 and this bottom equation by 4. If I do that, the y coefficient in the first equation, -4 times 5 would be -20. In the second equation, I would have 5 times 4 is +20. Those are opposites, so they add to 0. So that's what I'm going to do. I'm going to take this top equation, and I'm going to multiply that by 5. And I multiply both sides, everything on both sides, by 5. So I distribute the 5 across the 2. I distribute the 5 across the -4. I distribute the 5 across the 10. All right, now I'm going to multiply that second equation by 4, and I'm going to multiply everything by 4. I'm going to distribute that 4 across the 3. I'm going to distribute that 4 across the 5. I'm going to distribute that 4 across the 4. Okay, now I'm going to add that second equation. I'm going to add this equation here. I'm going to add that equation to this one here. So I have 12x plus 20y equals 16. And what I intended to happen, happened. The -20y plus 20y is 0. 10 plus 12 is 22x. 50 plus 16 is 66. So we're going to divide both sides by 22. And we're going to get x is 3. 66 divided by 22 is 3. All right, so now I need to figure out what y is, so I can back substitute in either one of those equations to find y. I'm going to choose the second one. And again, it's because there's no negative in front of that y. If I can avoid negatives, I'm probably going to do that. So we're going to replace the x with the 3 we found. And we're going to solve this for y. 3 times 3 is 9. Move the 9 over by subtracting it from both sides. 4 minus 9, the difference in 4 and 9 is 5. The 9 is bigger, its sign is negative, so that's -5. So y is -1. So it appears the solution is 3, -1. I would definitely check that because as I saw on the previous problem, if I hadn't checked it, I would have got it incorrect. So I'm just going to do a quick plug up here at the top. So I have 2 times 3 minus 4 times -1. Is that equal to 10? Well, that's 6 plus 4, so that is 10. Do it in the second equation. Is that 4? Well, 9 minus 5 is 4, so it does check. That is the solution. Okay, problem 13 is another solve, and it says use any method that I choose. Well, I choose to use substitution. Since this top equation is solved for x, I can replace the x in the second equation with that expression. So I have -4 minus 4y plus 4y is -1. Oops. So what I did is this right here is the expression for x. I replaced x in the second equation with that expression. Now what happens over here though? -4y plus 4y is 0. If the coefficients add to 0, then those terms are going to add to 0. So I end up with -4 equals -1. Well, that's not true. -4 does not equal -1. So since I attempted to solve this system and I ended up with a result that is not true, there is no solution to this system of equations. These are actually parallel lines. And if I were to solve both of them for y and graph them, I would see that. All right, so the next one, solve by the method of my choice. So I'm going to use addition because that's the method that I prefer. And I look at the coefficients on the x's. If I just multiplied that top equation by -3 and added it to the second one, I would eliminate the x's. So I'm going to multiply this top equation by -3. So let's go over here and do that. So I have -3 times 2x plus 5y equals 3. And I'm going to distribute that 3 across everything. So -3 times 2 is -6x. -3 times 5 is -15y. And -3 times +3 is -9. Now I'm going to add that to the second equation. So my second equation is 6x plus 15y is equal to 9. And I'm going to add that to that equation. Can you see what's going to happen? Well, 6x minus 6x is 0. 15y minus 15y is 0. So the left-hand side of this is 0. On the right-hand side, 9 minus 9 is also 0. So I end up with a statement, an equation that's just true. Yes, 0 is equal to 0. If I end up with an equation that is just plain true, 0 is 0, or 2 is 2, or 3 is 3, whatever, that means these are actually the same line. So any ordered pair that lies on that line is a solution. So we're going to choose the second choice here. There are infinitely many solutions. The solution set is any ordered pair xy such that 2x plus 5y is 3, or you can list the second line. It's the set of all ordered pairs xy such that 6x plus 15y equals 9. It's the same line, but there are infinitely many solutions. All right, we're going to look at some inequalities now. So to graph a linear inequality, you're going to first graph the line. Now, since my inequality is less than or equal to, we're going to graph this as a solid line. So in my lab math, when I choose my line tool, I'll go down in that toolbox and make that line a dashed, not a dashed line, it'll stay a solid line. You got a choice, you can keep it a solid line or you can make it a dashed line. Since this is less than or equal to, we're going to keep it as a solid line. Okay, I'm going to graph this using slope intercept. That would just be the easiest way to go since it's already solved for y for me. So the slope is 2. I'm going to write that as 2 over 1. And the y-intercept is 3. So we're going to plot the y-intercept right there and then use the slope. We're going to go up 2 over 1. So we're going to end up at the point 1, 1, 5. Okay. So draw your line. And since this is a linear inequality, we're going to shade. So in my lab math, you're going to pick the bucket tool from the toolbar, and you're either going to click the button above the line or click the button below the line. And one of the easiest ways to determine if you click the bucket above the line or below the line is to look at a test point. So typically you pick 0, 0 because it's just the easiest point to substitute into the inequality. So we're going to pick a test point. And we're going to pick 0, 0. The origin is just the easiest thing to substitute. And then we're going to plug it in. We're going to plug it into the y is less than or equal to 2x plus 3. So 0 for y, 0 for x. 0 is less than or equal to 3. That's not true. Oh, wait a minute. That is true. Lisa. That is true. 0 is less than 3. Yes, it is. And since 0 is less than 3, 0 is in the solution of this inequality. So you take your bucket tool and you shade below the line, because below the line includes the test point 0. So you take your bucket tool, not your eraser, which my note app just erased. We take our bucket tool. So I'm going to take my shading tool and we're going to shade below that line. My grandson changed it to a dashed line, so I'm going to change it back. Okay, so you would shade below here. And you just take your bucket tool and you click in that area and it will shade everything below. All right, problem 16. You're going to have a problem where you're going to be graphing either a vertical or a horizontal inequality. This is vertical. Excuse me, it's horizontal. Don't listen to me. Don't listen to what I say. Listen to what I say. This is a horizontal line, and we're going to graph this as a dashed line. And we're going to graph it as a dashed line because we have less than. So since it's less than, we're going to graph that line as dashed. It's a horizontal line at y equals -4. So we're going to take our tool in my lab math. We're going to pick the line tool. We're going to make that line a dashed line, and then we're going to plot 2 points on that line, y equals -4, and then we're going to decide how we shade it. Now, for horizontal and vertical lines, it's actually fairly easy to shade. If it's a horizontal line and it's less than, you're going to shade below. If it's a vertical line and it's less than, you're going to shade to the left. If it's a horizontal line and it's greater than, you're going to shade above. If it's a vertical line and it's greater than, you're going to shade to the right. So we're going to shade below. So we take our bucket tool and we click below that line, and that shades the correct solution. Okay, we're going to graph a solution set. So we're going to graph both of these inequalities, and we're going to look where the two inequality shaded regions overlap. That's what we're going to look for. So let's graph that first one. It looks like both of these are going to be dashed lines. They're going to be dashed lines because we have less than and we have greater than. We don't have equality. So we're going to graph both of these as dashed lines. So I'm going to graph the first one. I'm going to use intercepts on both of these. And again, this is going to be dashed. So the x-intercept, I set y equal to 0, divide by 3. So the x-intercept is 2. I'm going to set x equal to 0, so I get y is equal to 6. So we're going to graph 2 and 6, and we're going to graph that as a dashed line. Let's see how well I can do this. Okay, and now I'm going to look at look at just the solution for this. 3x plus y is less than 6. So my test point is going to be 0. Is 0 times 3 plus 0, is that less than 6? And the answer is yes, 0 is less than 6. So that is true. So 0 is in the solution of this. So I'm going to shade that. I'm not going to actually shade it in my lab math. I'm just going to make a note that it's going to be over there. Now we're going to graph the other line, the other inequality. So I have x minus y is greater than 4. So we're going to graph there we go. X minus y equals 4. So the x-intercept, set y equal to 0 is going to be 4. Set x equal to 0, and the y-intercept is going to be negative 4. Okay, so we're going to graph that. So we have y is negative 4 and x is positive 4. And we're going to again graph that as a dashed line. Okay, and then we're going to test the inequality. So if x minus y is greater than 4, so we're going to test 0, 0. 0 minus 0 is not greater than 4. That is not true. So we're not going to shade the part that contains 0, 0. So we would shade below. So I'm going to do that maybe in green. So where do those two shaded regions overlap? They overlap in here, right here. So I am going to shade that region using my bucket tool. So taking my bucket tool in my lab math, I would click in that area right there, and my lab math would shade that area for me. So again, the reason it's that area there, for the first inequality, it was the area to the left that we shaded. For the second inequality, it was the area below. And so where those two overlap is that area that I've got shaded there in the gray. And that's where I would click my bucket tool in my lab math. All right, we're almost done here. Problem 18. Find any intercepts for the graph of the linear equation and then graph the equation. So this is actually out of order because this is from earlier in the chapter. We're going to find the intercepts. This is a little tricky to graph because of the graph grid that you have in my lab math, so be careful. All right, so to find the x-intercept, we set y equal to 0. Divide by 2, x is negative 3. So the x-intercept, and they're wanting us to write this as an ordered pair. The x-coordinate of an x-intercept is that value, and the y-coordinate is 0. Okay, now to find the y-intercept, we set x equal to 0. So we get 0 minus y is negative 6. I guess we should say 2 times 0, but it's 0. And then we're going to divide by negative 1 because there is a negative in front of that y. So we want to divide by negative 1, and that is positive 6. So the y-intercept is 0, 6. So we're going to plot negative 3x and 6 for y. All right, so we have those plotted, and we can draw a line between them. All right. Graph the equation using the slope and the y-intercept. And I said the grid above was the one that was difficult. It's actually this one that's difficult because the y-intercept is 7. The constant is the y-intercept. So it's 0, 7. And the slope is 4/3. So I'm going to have to plot that 7 on that vertical axis. And it's going by twos. So it's 2, 4, 6. So 7 is right there. And you're going to take your point, you're going to take your line tool, and you're going to take that line tool and you're going to click right on that 7. And the nice thing about the graphing tool in Pearson MyLabMath is up in the upper right corner, it will tell you what point you're on. So you're going to make sure that you're on that y-axis and you go up to 7. Now the slope is 4/3. So you're going to start at 7 and you're going to go up 4. So you're going to end up at 11 in the y direction. And then you're going to go to the right 3. So you're going to end up at a point 11, 3. I'm going to go up 4 from 7 and over 3 from 0. So I'm going to find 11, 3. 11, 3 is right there. Because in the horizontal direction, again, we're going by twos. It's 2, 4, 6, 8. And I want 3, so I'm going to be halfway between 2 and 4. And then draw my line. All right, last problem. Woohoo! Given the point slope equation, state the slope and the indicated point of the graph. The slope is the number outside those parentheses, because remember, point slope form is y minus y1 is m times x minus x1. So this number outside those parentheses is the slope. And then the point, the x coordinate of the point is whatever you're subtracting from x, because that formula is x minus the x coordinate of your point. So we're subtracting 3. So the x coordinate is 3 of that point. But over here, we're adding 2. Since it's y plus 2, that means it's y minus minus 2. So it's y minus minus 2 equals -7 times x minus 3. So the y coordinate of my point is -2. So the slope is -7 and my point is 3, -2. And that is the end of the review. If you have any questions, don't hesitate to contact me.